Hi everybody, welcome to my channel, Numbers with Nora. This is a math tutoring channel where you can get free math help, ask questions, and just get all your math needs. So for this video, we're going to be continuing doing geometry, chapter 4. We're going to be working on 4.3, which is proving triangles congruent by the side, side, side postulates. Okay. And we're going to see the other postulates too as we go on in the chapter, but this is the first one that they introduce us to. And again, if you want to follow along, I'm using Larson's Geometry. There's a link in the comments where you can click on and get access to the book. It also has some free online stuff, which is really good to practice with for geometry. But if you're just using your own math book, that's fine. You can still follow along. All right. So first, the objective for 4.3 is you will use the side lengths to prove triangles are congruent. So first, let's look at the postulates that we'll be dealing with. Again, they call it SSS. This is usually referred to as side, side, side. And it's just basically showing that all the sides of both of your triangles have corresponding congruent sides. All right, so if we can sit there and prove this, then that can sit there and show that both of our triangles are congruent. All right. So let's hop into the first example right here. For example 1, it says use the SSS congruence postulate and write a proof. For this one, we're going to write a 2-column proof where we have our statements. I'll just put S for statements, and then our reasons, and I'll put R for reasons, right? And then we write it, split it in half like that. So it says given that KL, and they have all of our markings for us already there, KL congruent to NL, and then KM congruent to NM. They want us to prove that KLM, our triangle, is congruent to NLM, all right? And we have to use our SSS congruence postulates. So the first thing we always write down in a 2-column proof is our given, all right? And again, just for saving time, I'm going to let you guys sit there and write down the given as your number 1. And when you write down your given, you're just writing down literally everything they give you, right? So let's think about it. For using SSS postulates, that means that we want to show that all of our corresponding sides, we have equal corresponding sides. So we want to show that this side is congruent to the other side of the triangle, right? So in order to do this, remember in my last video, we use the reflexive property, right? So I can sit there and say LM, right? Congruent to ML. Okay, and this is by the reflexive property. And just put a property. And that's going to come up a lot in chapter 4. And we're going to use it in a lot of these proofs that we're doing to show triangle congruency. All right. And so then now that we have that all of our sides have corresponding congruency, we can sit there and say that triangle KLM is congruent to triangle NLM. And then we put what postulate we use. And this is by SSS congruence postulate. And sometimes you can just put postulate, but congruence postulate. Right. And that's it for that. Not too bad. Side, side, side is one of the easiest ones. Okay. So now let's go on to example number 2. This one I threw in there because they have a lot of good practice for the standardized tests in this book, which I like. And these might pop up on some of your SATs or some of your homework problems and stuff. So this one is, which are the coordinates of the vertices of a triangle congruent to triangle PQR? So we have PQR, and we need to sit there and find out which of these coordinates would sit there and give us a triangle that's congruent to this, right? So we're looking at our sides. So let's first find the sides of the triangle that they give us. We could sit there and use the distance formula to find the sides of PQR. But I believe we only have to use the distance formula for this PR. The other ones we can count since it's on a grid, right? So we have PQ being 1, 2, 3, 4. Okay. And then this one being 1, 2, 3. Okay, distance. Now for R, we're going to have to use the distance formula because it's kind of hard to sit there and tell how many squares of distance they are. So they give us our coordinates for this one, or we can find them on here. So that's -1, -2, -3, -4, -5. Okay. And let's see how much I go up. 1, 2, 3, 4. I go up 4. So our coordinates are going to be -5. Okay, that's my x's, and my y's is up 4, +4. Right? And then the coordinate point for R is going to be 1 or -1. My apologies. And then up 1. Okay, so that's going to be -1, 1, 1. All right, so let's go ahead and use the distance formula to sit there and find what the distance between P and R are going to be, right? So using the distance formula, I'm just going to sit there and plug in my x's and my y's. All right, so I have D equals, I have square root. Again, when you're taking a test, what I always like to do, because I see a lot of people make this mistake, especially in Algebra 1, I see it a lot when you're finding slopes, is why not go ahead and label what you're going to use as your x of 1 and your x of 2. And the same thing with your y's. Go ahead and label what you're going to use for your y's. I usually do this when I'm taking tests, so I make sure, just double make sure I'm not making a mistake. Y sub 1 and y sub 2. Okay, so that way when you go ahead and plug it into the formula, you're seeing exactly what you plug in. All right, so let's find the distance between here. So I do my -1 minus my -5, -1 minus, again, we have to account for that negative. Okay. And then square it. And then plus, again, plugging in my, this is going to be +1 minus 4. And then we square it. All right, and we're just solving this down. Under my square root, what I'm going to get is -1 plus 5, because those negatives cancel out and equal a plus. I'll get 4 squared. 4 squared is 16. And then plus 1 minus 4, that's -3. -3 squared, that's going to be +9. Right. 16 plus 9, that's going to be me 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Still under my square root 25, that's going to give me 5. Okay. Oops. Equals 5. So that means that the distance right here is going to be 5. So that means I want coordinate points that are going to give me the same kind of distances that I have here. Okay, 5, 3, and 4. So we already did. No, let's go ahead and do, let's see if A will work. right? And I'm going to do the distance formulas pretty quick. So for this one, I'm using -1 and 1, and then -1 and 5. Oops. Sorry. -1 and 5. Had a glitch there, sorry. All right, and so we're going to plug these 2 points into the distance formula. All right. So then I get 5, or -1, minus -1. And again, if you have to sit there and label yours, like your x of 1s and your x of 2s, go ahead and do that. And then plus, I have 5 minus 1 squared. All right. Then we square root it. And I'm going to get -1. Of course, that turns into a plus. -1 plus 1 is going to get me 0. 0 squared is just 0. 5 minus 1 will give me 4. 4 squared is 16. Okay, that just gives me the square root of 16. Square root of 16 is just going to give me 4. Okay. Now you would do this for -1 and 5, -4 and 5, and then you would also do it for these two as well, plugging them into the distance formula. And when you do plug them in, you will get 4, 5, and then 3, which come out with the same sides. So since you have the same sides, you can say by side, 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 A would be your answer. Again, I have to rush through this one because of time purposes, but if you want to see it hand by hand, all the other distance formulas, when I put these points in, put a comment in, and I do not mind sending you all my work for that. Okay. So our last one is going to be a real world problem. So this one says, explain why the bench with the diagonal support is stable, while the one without the support can collapse. Okay, so we just want to understand why this is possible. Before I sit there and sit there and explain the explanation, let me show you what's going on here. So for this one, the one that has the diagonal, notice it forms like 2 triangles. Okay. It forms 2 triangles that share that diagonal as a side, which means that I can say, since these are parallel, these would be congruent. This side would be congruent. And then by the reflexive property, that diagonal side would be congruent as well. I'll give this one's 3 and this one 2. Okay. So that's kind of like saying by our side, side, side property that each one of these sides, I know no matter what, like how big you make this bench or how small, they're going to stay proportionate. Okay. They're going to have the same size and the same shape. Okay. Which is going to give it more support. So that's going to be why this one has more structural support. Okay. All right. So again, if you have any questions on your homework or any further tutoring, please subscribe or leave me a message in the comments. Thank you.